Balancing chemical equations can feel overwhelming, but it doesn't have to. Instead of wasting time counting every atom, I'll show you a fast, step-by-step method that works every time. Let's jump in. To balance an equation, we need the same number of each atom on both sides. Reactants on the left, products on the right. To make that happen, we use coefficients, and these are the numbers in front of a compound that multiply every atom inside it, like a number outside parentheses in math. If the same element appears in more than one compound on the reactants or product side, we add those totals together. And here's the golden rule. Never change subscripts, only coefficients. Now that you know the rules, let's go step by step. The checklist we'll use is start on the left with the first compound and underline the first element you see. Find that same element on the other side. If it appears once on each side, begin balancing there. If the element appears in multiple places, skip it and return later. Keep scanning left to right, aligning one element at a time until everything is balanced. And finish by making sure your coefficients are the smallest whole numbers possible. We don't need to keep recounting every atom, that just slows you down. Instead, think of it like snapping puzzle pieces into place. By the end, every element will fit perfectly. As we go, pause and try each problem yourself before I reveal the next step. The first equation we have is C₂H₆ plus O2 creates CO2 plus H₂O. Starting from the left, I will underline the first element in the first compound, carbon. I will then scan the equation for any other carbons and underline those. Carbon only shows up in one place on both sides of the equation, so this will be a good element to start with. On the left, we have 2 carbons, and on the right, we have 1 carbon. To balance, I need a coefficient of 2 in front of CO2 to make that 2 carbons as well. Carbon is now balanced. Moving to the next element, hydrogen, I will underline hydrogen in all places. It shows up in one place on both sides of the equation, so it is a good one to balance next. On the left, there are 6 hydrogens, and on the right, there are 2. To balance, I can put a 3 in front of H₂O to make it 6 on each side. Oxygen is the last element, and when we underline oxygen, it is in multiple places on the product side. Since those 2 compounds already have coefficients, we can add up those oxygens on the product side because we would rather not have to change those coefficients since carbon and hydrogen are already balanced. 4 plus 3 equals 7 oxygens total on the product side. This is an odd number, and O2 on the reactant side will not be able to equal an odd number. The trick here is to multiply all coefficients by 2 to double the amount of oxygens needed to be an even number of 14. Now I can put a 7 in front of O2 to have 14 oxygens on each side. We can recheck all elements. Carbon has 4 on each side, hydrogen has 12 on each side, and oxygen has 14 on each side. The equation is now balanced. Our next equation is NH3 plus O2 creates NO plus H₂O. Starting from the left, I will underline the first element in the first compound, nitrogen. I will then scan the equation for any other nitrogen atoms and underline those. Nitrogen shows up in one place on both sides of the equation, so this will be a good element to start with. There is 1 nitrogen on both sides of the equation, so we can leave them the same for now. The next element will be hydrogen. I will underline hydrogen in all places. Hydrogen only shows up in one place on both sides of the equation, so it will be a good element to balance next. For a 3 and a 2, I can make them both equal to 6. So I can put a 2 in front of an H3 and a 3 in front of H₂O to make each side have 6 hydrogens total. Because nitrogen was already balanced and I just changed the amount for nitrogen on the reactant side, I will now have to put a 2 in front of NO to keep nitrogen balanced. We now have 2 nitrogens on each side of the equation. The last element to balance is oxygen. We have coefficients in front of each compound on the product side, so it is best to add up the total number of oxygens on the product side. There are a total of 5 oxygens on the right-hand side, but O2 always contributes an even number of oxygens, so I will multiply all coefficients by 2 to make the oxygen count on the product side to be an even number of 10. I can then put a 5 in front of O2 to make 10 oxygens total. Oxygen is now balanced. We can recheck all elements. Nitrogen has 4 on each side, hydrogen has 12 on each side, and oxygen has 10 on each side. The equation is now balanced. For the next equation, we have Al plus Fe₂O₃ creates Al₂O₃ plus Fe. Starting from the left, I will underline aluminum first. Aluminum appears once on each side, so it will be a good element to start with. On the left, we have one aluminum atom, and on the right, we have two aluminum atoms. I will put a 2 in front of Al on the reactant side to make aluminum equal on both sides. Aluminum is now balanced. Next, I will underline iron. On the left, we have 2 iron atoms, and on the right, we have 1 iron atom. I will put a 2 in front of Fe to have a total of 2 iron atoms on each side. Iron is now balanced. The last element to balance is oxygen. Fe₂O₃ has 3 oxygens on the reactant side, and Al₂O₃ has 3 oxygens on the product side, so oxygen is already balanced with the coefficients we placed. We can recheck all elements. Aluminum has 2 on each side, iron has 2 on each side, and oxygen has 3 on each side. The equation is now balanced. The next equation is H₂SO₄ plus NaOH creates Na₂SO₄ plus H₂O. Starting from the left, the first element in the first compound is hydrogen. When I underline hydrogen in all places, I see it is in multiple places on both sides, H₂SO₄, NaOH, and H₂O. So hydrogen is not a good one to start with. I will skip hydrogen for now. Next, I will underline the sulfate group, SO4. Because SO4 stays together on both sides of the equation, and I see one SO4 on each side, sulfate is already balanced, so I will leave it as is. Now I underline the next element, sodium. Sodium appears once on each side, but on the product side, Na₂SO₄ has 2 Na, while NaOH has 1 Na on the reactant side. To match, I will put a 2 in front of NaOH. Sodium is now balanced. I will return to hydrogen. On the left, I now have 2 H's from H₂SO₄ and 2 H's from the 2 NaOH, for a total of 4 hydrogens. On the right, hydrogen is only in water, so I will put a 2 in front of H₂O to make 4 H's on the product side. Hydrogen is now balanced. Finally, I check oxygen. On the left, there are 4 oxygens in sulfate and 2 oxygens from the 2 OH groups, totaling 6 oxygens. On the right, there are 4 oxygens in Na₂SO₄ and 2 oxygens in the 2 waters, also 6. Oxygen is balanced. We can recheck all elements. Sodium has 2, sulfur has 1, hydrogen has 4, and oxygen has 6. The equation is balanced.